គាត់បរៀនហ្នឹងយើង note ទុកអីផងហើយlecture ហ្នឹងគាត់នឹង share យើងនឹងបន្តដែរទេហើយតាក់ទងជាមួយនឹងនេះហ្នឹងគឺយើងនឹងមាន quiz តាមក្រោយអាហ្នឹងខ្ញុំ design ធ្វើ quiz ឲ្យយើងធ្វើតាមក្រោយអញ្ចឹងពេលយើងរៀនហ្នឹងយកចិត្តទុកដាក់យើងកត់អីផងណាហើយតាក់ទងមួយនឹងភាសាគឺយើងប្រើភាសាអង់គ្លេសហើយអញ្ចឹងមានសំណួរអីគឺយើងអាចសួរបានអាហ្នឹងគឺតើយើងក្លាហានដែរណាអញ្ចឹងខ្ញុំមានក្រីឲ្យពួកយើងរៀននិយាយបានច្រើនហ្នឹងឯងអញ្ចឹងឥឡូវពួកយើងចូលមក submit attendance មក Okay, hello.
Hello.
Can you hear me? Can you hear me?
Yes. Can you hear me?
Okay. That's good. I can hear you well. So just now, like they already joined the class. So as we have discussed earlier, like we will have a joint teaching program with a university in Indonesia, and Mr. Yudihi will be joining our course today. And actually, we will have about 3 or 4 sessions meeting with him. And the first week, the topic here we will discuss. We talk about the abstract data type. Actually, in addition to our curriculum and this semester, we will learn more advanced data structures. So in here, like we also provide additional lectures covering on various data types. So I hope everyone can understand more about the data structures and data type. So next, I will give the session to Mr. Yudihi, who is currently a lecturer in data structures and algorithm course at Indonesia University. Thank you. And I think it is okay if the internet is not stable, like you can enable, like turn off the webcam. It's fine. It's okay. Thank you.
Okay. Thank you, Mr. Chana. Hello, everyone.
Oh, hello, teacher.
Hello, teacher.
Hello, sir.
Let me introduce myself. My name is Yudihi Paramartha. I am from Universitas Pendidikan Ganesha, or in English it is Ganesha University of Education. So we have an education university in Bali. We are from Bali. And now I will give you a lesson about abstract data type and the overview about the primitive data type. I think you all have familiar with the primitive data type, or in the C++ you call it the primary data type. So let me share my screen to you. This is, I'm not familiar with Microsoft Teams, but I think I will try. Okay.
Okay, that's good. We can see it well. Okay.
Yeah. Yeah, I'm sorry that maybe this is my first time teaching in English actually, so maybe some of my pronunciation or the language that you don't understand, just tell me about it. And when you have any question, don't hesitate to call me or tell me, okay? Okay, our lesson today is about primitive data type, and this is the primary data type in all programming language, I think. And then we move to the abstract data type. What is the abstract data type is, and how we could do or manipulate the data type using the some algorithm or operation that you will use it in the data, the structure. I am from study program of computer science from Universitas Pendidikan Ganesha or Ganesha University of Education. And I am from Bali. Maybe some of you familiar about Bali, right? You know about Bali?
Yes.
Yes.
Maybe some of you happen to go to Bali before. Have you? There is anyone that went to Bali before?
No. No, teacher.
Yes. I hope that you could come to Bali. I heard what I learned about Cambodia several times. Maybe from the television and something like that. Your history is very interesting, I think. I learned from the Wikipedia about your culture, and yeah, that's interesting. I think that our joint program like this could make us closer and exchange our culture. I don't know much about culture in Cambodia, and maybe you don't know much about my culture in Bali. So don't hesitate to ask me about something like that. Okay. My formal education is from Universitas Indonesia, one of the university in Indonesia, in Bachelor of Information System, and then my master degree in computer science in the same university. So I never went study to overseas. So this is my first time teaching you about a lecture here, and my work experiences. Maybe several years ago, I am a programmer for several company in Indonesia, and then I am become a lecturer in Universitas Pendidikan Ganesha for about 6 years now. So I'm not a senior lecturer in my university, and some of my courses that I take is about distributed system, and then data structure algorithm, and then object-oriented programming. So maybe some of the programming and sometimes I teach about a distributed system like cloud computing or something like that. Okay, maybe that's my introduction. Maybe before we start our lecture, do you have any question? I don't know how to see you in this in Google. Sorry, in don't know how to give a control. Okay, there is a control. I think. Okay. Okay. Maybe we could start our lecture now. Do you still with me? Because I have some notification about bad network connection. You still hear me?
Yes.
Yeah.
Yes. You hear you.
Yes.
Okay.
Yeah, teacher.
Okay. Our outline for today's topic is about the primitive data type, especially in C++. I think you very familiar about the primitive data type in C++. In C++, you call it a primary data type. And then about the signed and unsigned data type, sometimes when we structure a data type, we have to know about is there our data need signed type or unsigned type? And we will discuss it about it. And because some of primary data type is not enough for our needs, so we have to what and I call it, we have to create some of the data type, and then what operation of the data type, and then we will learn about the concept of abstraction, and then some example of ADTs and some concern of ADTs, how we could create good ADTs. Okay, maybe our course in Undixa and you from ITC is a little bit different because your course name is Algorithm and Programming too, I think, and my course called the Data Structure and Algorithm. And then about the programming, we usually have some what I call it, different courses, especially for programming. So usually we are in Undixa have the theoretical side of the data structure, and then the programming we will have another courses in the same semester. So maybe in this lecture, I will not give you some programming lesson, but about the concept of about the abstract data structure, okay? The first lesson is about primitive data type. I think you're very familiar about the primitive data type. And in C++, you call it the primary data type. For example, on integers, and then characters, and then Boolean, floating point, and maybe longer floating point called double, and then void when you don't have any return type, you could use the primary void, and then you maybe need some white character, something like ASCII or something like that is very short, and then we maybe need a wider character. So I think you all very familiar about it. For example, an integer is the number that doesn't have any floating point. So we can use the integer type to something that simple mathematics. For example, addition, subtraction, multiplication, and something like that. Or we could use the primary data type with the operation like it is greater or lesser or something like that, or it is equal, something like that. So you could use the primary data type to many things, but sometimes we don't know is there the data type for our information system, for example, or our algorithm, is it enough or not? So we have to try to see that maybe some of the algorithm need several data type. For example, in C++, we have something that they call it derived data type. For example, function. I think you're familiar with function, that we create some of our code is wrapped together into a function. And then maybe there is some return type, for example, integer or something like that, or maybe there is no return value from the function, and then we could use the void keywords in the code, and then something like an array. I think you familiar with array. The array is the collection of a data with the same type, and we have to what I call it. You have to initiate how long the array is, how long the data that we have to insert to the array. So this is very fast data type, and it is very useful for several algorithms. And then we have something that called pointers. Maybe some of you familiar about the pointers, and I think Mr. Chana will give you the concept of pointer next week or several weeks from now. I will have give you some knowledge about pointers, but not as deep as when you will learn in the next week, I think. And then there is some reference. Maybe sometimes we using pointer or something like that. And then other than primary data type and derived data type, we usually have a user-defined data type. The user-defined data type is the data type that we could create outside the derived or primary data type. For example, when we learn about object-oriented programming, I think you will have the next semester or 2 semesters from now. There is a concept that called classes. The classes is the collection of function. We call the function is methods and the attributes of the function wrapped together into a class. And the class can be initiated. I'm sorry. Do you have any question?
No.
Okay. And then, yes, maybe something like that. And we could have some structure in the class. And then we could make something like other data types. That's what we will learn about it, okay? And then maybe something like union and enumeration and type depth data type. Maybe you could learn it by yourself, okay? Maybe from here, do you have any question before we go to the next slide? Do you have any question?
Teacher, can you explain again what is the difference between character and white character?
Okay. Do you familiar about ASCII? ASCII, ASCII. Do you familiar about that?
Yes, teacher.
How many the range of the ASCII? Do you know? How many range of the ASCII?
There are 266 ASCII code.
Yeah. Yes, 256 ASCII code. But sometimes we use some of the character that doesn't belong to the ASCII. For example, maybe Japanese character, for example, and Chinese character. There is no Japanese or Chinese characters in the ASCII. So we need a wider character range. For example, Unicode and UTC, UTF or something like that, okay? So when we see like this, the primary data types, say size and range, you could see that the character is about 0 to 255 in the range, okay? And then maybe when we use the wider character, for example, UDF, maybe the range is about 16-bit or 32-bit. It is a very wide character. That's called the wide characters. But sometimes the wide characters is very what I call it, very specific to other system. For example, when you have the older computer, maybe the character is not supported, but I think the modern computer supported many range of the characters, something like that. Do you get it?
Yes, teacher.
Okay. About the range of the size of the data type, for example, Boolean is the size is 1 bit and the range is 0 and 1. It is called the true or false. It's the very basic data structure. Data type in our computers. And then maybe something like character, chair, car. I don't know how to pronounce it. It is about 8 bits and the range is about 0 to 255. And every range and every number in the range will be represent specific characters. For example, 65 is for I think it's capital A, I think. Okay, well, I don't know, I don't remember about it. And then some things like numbers, like short is 16 bit from 0 to 90,000, and then integer is about 16 bit, I think. But some implementation of integers is not always 16 bit. Something like in Java, for example, it is, I think it is 32 bits. It's very specific to the programming language, okay? And then the longer integers in C++ we call it long. It's 32 bits, about 4 million from 0 to 4 million, 4 billion, sorry. And then we have a float. It's about 16 bit. Maybe it's very similar to integer, but there is some floating point number behind the number, okay? And then the double is a float, but it is much longer range for the float. But something that we have to learn, some things that maybe we miss about the data structure or primitive data structure is about the signed data structure. For example, the integers is, the range of the integers is minus 32,768 to 32,767. Okay, so it is 16 bit, but we have a minus integers, and then we have positive integers, and we have negative integers. But sometimes we need the data structure that doesn't need a minus number. For example, when you're counting something, you're counting how many students in your class. You don't need the number, the negative number, right? So you don't need to represent your data structure with the signed integer. So you could use the unsigned integer to make it more useful, I think. And then how could you do it in C++? You just give the keyword unsigned in the front of the declaration. So, for example, integer, you wrote on your code editor to unsigned integers, and then the variable name, something like that. Then maybe I could give you some example. For example, you declare a variable a, an integer type, something like this. But when you want the a type is unsigned, you just write it like this: unsigned a, unsigned integer a. So with these keywords, you tell the compilers that the number that I have is unsigned, or there is no minus number in the data that we have, something like that. Okay, and so on, and something like that. I don't know why the character is have the unsigned signed characters. I think I don't know what this is about, because about when we declare the character, it's always unsigned. Okay, but for the numbers, is maybe we could get the unsigned character numbers or signed numbers. Okay, and how about the representation in the memory, for example? For example, we have a number, 8-bit number, for example, is short. The value between the unsigned number, unsigned number of 8 is 0 to 255. Okay. There's no problem when we only need a positive number. Okay. It is okay when we only need a positive number, and when we see the memory state in the in your computer and the memory, when we declare the 8 bits number, they will allocate 8 block of the memory in bits. Okay. So, for example, memory state like this, there is 8 block, 1, 2, 3, 4, 5, 6, 7, 8. And when all of the numbers is 0, then it will give the 0. I think you very familiar with this about the binary number, okay? And then you convert it to the decimal number. And when you have the memory state, 7 of the numbers is 0, and the least number is 1, and it gives you 1. Okay. And then when you declare all the block of the memory state is 1s, then it will return to 155, the number of 255. I think it is okay. But how about the negative number? Maybe I will ask you how the computer represent the negative number for 8-bit numbers, for example. Maybe someone could have sorry? Could you give me some answer for the problem? How about the negative number? I'm sorry. Okay. Yeah, I'm sorry, I'm not familiar with the Microsoft Teams, so I couldn't see you in the student list isn't showing. Okay. Okay.
Can you see the person logo or something on top right? There is a participant. Yes. When you click and then you can see them as a list.
It just only have a give control drop down and stop presenting, something like that. But there is no other menu.
Okay. Maybe it's related to permission or something.
Okay.
I will check it. I will check it later and grant you a permission.
Okay.
Then.
Okay. Maybe I will give you the answer. It's when we declare for a number is 8 bits, in the memory itself, it will be what I call it? Give you 8 block of memory, something like that. When you have a negative number, it is the same. You only have the 8 bit of memory. There is no 9 memory or something like that. So how about the negative number? Okay. How you represent the negative number is by using the first bit of the memory state to sign the positive or negative. For example, like this. Okay. We have 8 block of memory state, something like this. 1, 2, 3, 4, 5, 6, 7, 8. But the first bit of the memory state will be used to sign the positive or negative. For example, when you the first bit you have 1, it is representation of negative number, something like that. And then when the positive number is 0, something like that. So for this example, for example, we have the first memory state is 1, and then the rest of the memory states is 0. Then usually you have 127 positive number. But when you declare that your computer into unsigned integer, for example, then this memory state will not be used as a number itself, but as a sign. So this is the seventh memory state is 0, you know, because all of the memory state is 0, it will give you 0. But because the first of the bit is 1, then it will be 1 minus 128 minus 0. Then you will give minus 128. And then, for example, all of the number here is 0 except for the last one is 1. Then when you convert it to the decimal, it will give you 127. I'm sorry. It will give you the number 1, okay? But when it is a representation of the first memory bit is 1, then the number 1 will be subtract by the 128. That gives you minus 127, something like that. And when all the memory state is 1, then the 7 memory bits, something like this, will give you 128. Okay, and then because it's a negative number, you could subtract it 128 to minus 127. That makes you give you minus 1, something like that. How about the positive number? It is straightforward. When the first bit is 0, then the rest memory state will give you the binary representation of the number, okay, something like this. So that's how the memory give you the signed and unsigned integers, okay. It is very important because earlier, when early computer is present, the memory is very limited. For example, only several kilobytes, 2 kilobytes, 4 kilobytes is very limited memory. So we have to think about how make the memory is efficient, something like that. So we have to learn about this. We have to know about this, something like this. But maybe in our computer nowadays, it's very wide memories. For example, 8 gigabytes, 16 gigabytes is very wide. And then this is give you some opportunities to give to make a complex data structure and makes it very efficient. Okay, so that's how the memory were represented about some of the numbers, something like this. Okay, do you have any question? Do you have any question? Okay, maybe we go to the next slide. Okay. Are primitive data types enough? Maybe we have to question ourselves. Okay, as programmers, for example. We learn about the primitive data types. Okay, there's an integers, there's a characters, there's an boolean, floating point, and something like that. Are these data types is enough or not for our needs? For example, how about when we need a words? We knew that the characters represented with 8 bit of memory, for example, when we learned before. But how about words? How we represent words in C++? Could you answer it? How we represent words in C++? Okay. In C++, we could use a string. Okay. String is usually or what I call it, predefined data types that we could use to represent words. String itself is a sequence of characters. So this is a sequence of characters that makes a string, something like that. Okay, I think you're familiar with this. And then maybe the second question is, how about we need to store a series of data? What are the structures that we could use?
We could use array.
Yes, it is right. We could use array for when we need to store a series of data. But the disadvantage of array is the arrays, and then the type of the data that we could store is in the same type. Okay, for example, sorry, like this. We could assign an array, for example, integer a, and then we could declare the length of the array, for example, 10, and then we could do something like this: 1, 2, 3, 4, 5, for example, like this. Okay, maybe it's too long. Maybe I could declare it to 5. Now, there is no problem about it. But how about when we want to something like this? Test something like that. Is it possible with array?
No.
How? Why not?
I think because we declare it as an integer.
Yes, because we declare it only for the integers. It is not possible. Okay, so we could use something like this. Okay, only could use something like this. Maybe some other question. For example, integer b, and we declare it to 5 in length, and then we assign the number. For example, 1, 2, 3, 4, 5, and 6. Is it possible?
No.
Why not?
Because the size of array only 5, but the data we have is 6, so it means that it's more than the array that we declare.
Yes, it's called overflowing. Overflowing. So the data is overflowing because we only assign the memory for 5 integers, and then we declare it for and we assign 6 number to the array, so it's overflowing. Okay. How about this? We have the integer c. Okay. They have 5 in length, and then we declare only 1, 2, and 3. Is it possible? Okay, is it possible?
Yes, it is possible.
Yes, it is possible, but how many memory blocks that we use to when we declare something like this? How many memory blocks that we use?
5.
Because we declare it for, sorry, yeah?
3 block to use.
3?
I think it still use 5 blocks.
Yes, we're still using 5 blocks of memory, okay? So how about the 2 blocks that we don't use? How about it? Could we override with other data other than C? The answer is not possible, okay? So when we have declared the integer to 5 blocks of memory for something like this, and we only assign the number of 3 number to the arrays for something like this, some programming language still have assign the memory for something null, something like this. Okay? They will be assigned as null, but the memory could not be reused by the other variable, something like that. Now, how about something like this? We have a problem. Okay, we have a problem. We will. I want to list all of my students. This the name of all of my students, for example. We could use, for example, string, something like this, and then we declare the variable student, for example, students, something like this. But the question is, how many block of memory that I will have to declare? How many? Maybe my student today is only 30 students, for example. So I could declare it to 30 block of memory, something like that. Okay. But how about the next semester? How do I know that 30 is enough? It is not possible, something like that. Could I declare it to 1000, for example? Yes, I could. But is it need to declare 1000? So when we use only the integer, something like this, when we use an array, the condition is we have to know how many data that we have to insert to the array. Okay, but when we don't know how many array, how many element that will be in the array, it's not recommended that we use an array, something like this. Maybe we could will happen like this, overflowing, because we don't declare the array enough. But maybe underflowing, something like this. We declare the array is too much, something like that. But the data is not that much. So some of this problem will be very problematic when we have the very limited memories. Okay, something like that. So we need something that we could. We need a new data structure that could solve this problem, something like that. Okay. Then that's the abstract data types. Okay, we will move to the abstract data types and what is the abstract data types and how we could create abstract data types. Okay, maybe do you have any question before we go to the next slide? Okay, maybe we could go to the next slide. Okay, the abstract data types. Imagine that you have a data, right? You need to insert some data, for example, a pair of student number and then the name of the student. Okay, is it possible using an array? When you need to need a data that composed of the number of students and the name of the student, and then there is many students that have like something like that to the same variable. Could you do that with arrays or something like that? It is not possible. Okay. The concept of ADT is how we, as a programmers, could make something that more complex than that, something like that. Okay, and then there is two considerations here. The first, the concept of specification. For example, maybe I could give you one example first, something like this. Suppose you want to drive a car, okay? You knew a car, right? And maybe some of you could drive a car. How are you doing it? That's the question. It's a very simple question. How are you doing it? How you drive a car?
First of all, I think to drive a car, we need to start the engine first.
Okay, and then?
And then you put like, I don't know how it called, to the drive mode.
Okay.
Yeah, and then you can push on the gas and your car will go.
Okay, something like that, yeah. All you need to know is change the gear. Maybe I don't know the automatic car, but maybe it's called the gear. You change the gear, for example, to drive, something like that, and then you push the accelerator, and then you drive the car. Okay, it is very simple, right? But the question is, do you have to know how the engine work when you drive a car? Do you have to know about that? For example, the gas will be the gasoline, for example, will be combined with the air, and then the combustion system do something, and then the piston of the cylinder will be doing something and something like that. Do you have to know about that when you want to drive a car?
No.
No. All you have to know is how to change the gear and how the accelerator works. That's all you have to know. Now that's called the specification. Okay? And then how the engine is working when you do acceleration, or for example, that's the implementation. Okay? Now, this is the consideration of the abstract data types. Sometimes when we using a data types, all we have to know is how to use it, not what algorithm that you use or something like that is sometimes is not it's not a problem. It's not a consideration. All we have to do is how the data types working and what operation that we could use in that data types. So I'm using the car as an example, that when you will want to drive a car, you don't need something like that. You don't need know how the engines work, but all you need to know is how to, for example, do the accelerator, do the brake, and steering the steer wheel or something like that. Okay, that's the concept of the main concept of abstract data types. We don't need something that too technical. The user don't need know about something that too technical. They only need to know how to operate the data. But we, as a programmers, we have to know how to build it, something like that. So when the example of the car, the engineer of the car must know how the engine works or something like that, and he must know how to drive a car before he could become an engineer, for example, the car engineer, something like that. Okay. Maybe I give you one example of the list on ADT. Okay. For example, we have a problem like this. We need an order collection of items of the element of type E. Okay, we have a element E that is composed of ID in integers and then item name in strings, for example, like that. Okay, and then we have to make a collection, something like this. Okay, and it is ordered by ID, something like this. Okay, the ID start from 0, 1, 2, 3, and so on. And then the item names is, for example, item 1, item 2, and so on, something like that. But the keywords here is order collection. Okay, we need an order collection. But when we want to insert the data doesn't need to be ordered. Okay, for example, we insert the data 5 first, and then we insert 6, it will be ordered. And then when we insert 2, for example, the ID 2, it will be ordered accordingly, something like that. So 2, 5, and 6, something like that. Okay. The question is, what the operation that you could think of in the data structure? Okay. For example, I give you one operation that we will do in the list. For example, adding the data. Okay. Adding the item to the list. We could use the operation, for example, because when we adding the data, there is no return type. So we could use void keywords, for example. And then the function name is add. And the parameter is E, okay? E is ID and name, something like that. The description is add item to the list. That's one operation that we could do in the list ADTs, okay? I will give, I want to ask you, other operation that you could think of to the list. What operation that maybe we will need to implement this data or manipulate this data? Do you have any
I think the operation is can be a search of to find item name by only import the ID.
No, the ID and item name is one set of data, right? One set of data. The ID is integers and then a name is a string, something like that. And then it will create a new type called E. The E will be inserted to the list, something like that. So, what operation do you think? Yeah?
Delete E.
Okay, delete. Okay. Maybe we could delete an item by the element name or the element ID or something like that. Okay, deleting, it is good. Maybe other example. Do you have any opinion about what operation that you could think of?
How about updating?
Okay, maybe updating the data by ID, for example. Okay, well, for example, the ID2 will be replaced with item name into item 26, for example, like that. Okay, okay, replacing the value in the item. Okay, in the list. Maybe some operation. There is opinion for some operation. Okay, you get the idea, right? So, for example, this is some operation that we could use in the list ADT. For example, add an item to the list and then removing an item by the position number, or maybe this is by ID, right? When we want to remove the item for ID2, for example, then we could use remove 2, something like that. And then maybe getting an item from the list. Maybe we want to know the information that maybe we want to know the item name of the ID 7, for example. We could use the operation get item, something like that. And the return value will be E. E is ID and item name, something like that. Okay. Maybe we want to check, are the lists empty or not? We could give an operation, for example, is empty. For example, we want to check our gas in the car. We could see the fuel gauge in your dashboard, something like that. So something like is empty is one operation that we could use in list ADT. Okay. Or maybe we want to know how much the item in the list, something like that. So we could use the size operation, and we will return the integer value of the how many item in the list, something like that. Okay. So this is the list ADT, one of the ADT that we could construct. Okay. So there is some question here in this example. For example, the list ADT. Maybe some of the people want to know how the item representation internally in the list, how the item is constructed in the list in the programming manners. Okay. And then maybe some question about when we do the add operation, because the specification is we need an ordered collection of item E. So how we order the collection in the list? How could you, what algorithm that you use? Something like that. Okay. That is the separation of concern. We call this a separation of concern. Okay, we back from here. Here, there is some specification. This specification is what kind of operation that you could perform in the in the data structure. And second is the implementation. What algorithm and how you do that, something like that. Okay. That's we call it the separation of concern. Okay. Do you have understand about this? About the list entities? Do you have any question? It is only one example. Okay. I will give you some example later from this course. Okay. So why we need an ADTs? Okay. Yeah, just like we discussed before, that users usually don't need to know about how we implement something in some objects, for example. All they have to know is what operation that they could perform in that object, or something like that. Okay, and then that's why we need to design a software that work as specified. We have in the specification, for example, we have some problem that could not be solved by the primitive data type. So we have to construct some software or design a software or data type that can solve the problem. But in spite of that, we need the software or the data type easily understandable and then easily modified. Okay, and of course it's reasonably efficient. We need an efficient data structure to do something like that, to do some operation. Okay, and the most important thing is maintainable. What I mean maintainable is when we use the data structure to the other problem, it will be compatible to their problem. Okay, that's called maintainable. So we need some level of abstraction. Maybe you're not familiar about abstraction, and I will give you a lesson about abstraction. And then we can use the data structure effectively based on the data type that we create to other problems, something like that. Okay. There is something, some concept in the ADTs about the abstraction. When you knew the ADTs is abstract data structure, there is one word that called abstract. Okay, so you have to know about the concept of abstraction. What is abstraction? Okay, the abstraction means omitting or hiding some low-level detail of the software. For example, we come back to the car example. Okay, the low-level detail is something, for example, how the engine works, something like that. That's called the low-level details. Okay, users don't need to know about the low-level details. That's why we have to hide the details. Okay, and then we only expose the high level detail. For example, the operation that we could do in the data, for example, something like that. Okay, for example, when we have a car, we expose for example, the gear, something like that, or the steering wheels. We expose that to the user, but we don't. The user did not need to know how the engine works or something like that. That's called the high level operation. Okay, the low details is, for example, the algorithm they use, something like that, and the high detail is about what the description of the operation, something like that. Okay, and the concept of abstraction is based on a modularity idea. Jadi, every operation that we will create will have the modularity. Okay, one problem or one data type to other data type will be modular, and we could integrate one data structure to another data structure easily with the modularity. Okay, the second concept of abstraction is based on encapsulation. Maybe you will be learned about encapsulation in object-oriented programming next semester, maybe yes, something like that. The encapsulation is the concept where many operation is wrapped together to one object. That's called the encapsulation. Okay, and then the next concept is about information hiding. We don't need to know the internal thing, the internal implementation of the data types. That's called the information hiding. Okay, and then the separation of concern. That, as I say to you, that we only knew the low-level details, and then we hide. We only knew the high-level details, and we hide the low-level details. That's called the separation of concern. Okay, thing like that. Do you have any question? Okay, maybe we move to the next slide. It's about the classifying the operation. For example, the list ADTs, we had some operation, for example, add, removing, getting data, and adding something, and maybe many other operation. And we could classify the operation in the ADTs. For example, the first classification is creators. Maybe you will learn about it in object-oriented programming. I'm not sure that you will learn about OOPs in this course, but in my student, we will give them the knowledge about simple object-oriented programming. So how we creating objects, we do something like this. The class name and then the variable name, we call this a variable or the object name, and then we could use the new operator or new keywords, and then the constructor of the list or the data structure that we will use, something like this. That's called the creators. The main idea of the creators is how we creating a new object or declaring a new object, something like that. Okay, and then the second classification is mutators. It's something like changing some information of the object. For example, the list ADT that we learned before, when we adding a data, there is some change in information in the objects, something like that. For example, before we have 2 data in the list, and then when we add something, it will be 3 data in the list. That's means that we're changing some information of the objects. That's called a mutators. Okay, and then we have classification called observers. Observers is something that observes something. For example, how getting item. For example, is there an item in this object? How many items there's in the object? Is the list empty or not? Something like that. That's called observer. Okay. And then there is one classification that called producer. Producer maybe it is similar to creators, but the what I can call it, the difference is the producer is creating new object from several old object. For example, the string x. Okay, we assign the value hello, and then the string y we assign the value world, and then the string z is composed of x and y. Then it will produce the z is hello world, something like that. This is called a producer. So the z and the operation x plus y is the producer, something like that. It's different from creators. When we talk about creators, the creators is something that's very new. Yes, there is no maybe some initialization, but it is usually empty, something like that. Okay. And producer is composing from other object to next object, something like that, and then we'll be creating a new object from that compose. Okay, something like that. That's the classifying the operation. Okay. Do you have any question? Okay, maybe because it is for we already 1 hour in here. Maybe we will give I will give you a break for maybe 5 minutes. So now is 1:07. Okay, in your time, okay, 1:07. Maybe we will start the lesson for 1:12. Okay, 1:12. I will give you a break. Thank you. I'm sorry, I'm mistaken. What I see is the recording time, not the actual time for today, so, for this time. So the recording time now is 1 hour and 12 minutes. I think we have still have time. Okay, but the actual time is 3:17 p.m. in Indonesia time, Central Indonesia time, and I think you have your time is 2:17, right? Because it is different time from my place here to Cambodia. Okay, maybe we start the discussion. How about the other data structure? Okay, maybe you will get some of the data structure here that I will inform to you. Okay. Some example of the ADTs, for example, the linked list, the stack, queue, trees, grab, and hashing. That's the some of the data structure or ADTs that usually taught in the computer science. Okay, and then some common operation of ADTs, for example, inserting data, deleting data, getting value, checking values, traversing, searching, and sorting or ordering, something like that. Okay, I will give you some example of the ADTs. For example, this one ADTs that call a linked list. Have you ever heard about linked list? Do you learn about it before?
Not yet.
Yes, I see your syllabus. I think next week you will have a lesson about the pointers, and then the next after the pointers you will learn about linked list, I think. Okay. What is linked list? Something like this. This is the representation of the linked list. So maybe we have some of the data, for example, the array that we discussed before. When we declaring some array, we have to declare how many array, how many data that we have, that we will insert to the array. Okay, but in the linked list, maybe the implementation of array could be some represented in a linked list, something like this. So it's very similar to the arrays, but the difference is the arrays only hold the limited number of element in the array. But in the linked list, we could theoretically have unlimited data on the linked list. How we could do that? Because we have a connected nodes for something like this. So we have a node A, B, C, D, and E. Suppose the A, B, C, D, and E, it is the data that hold in the linked list, for example, like that. Every linked list have a data field. This is the data field, for example, A, B, C, D, E, that's a data field, and a reference that connect every node to the next node. For example, this A, the next A is B, the next B is C, and the next C is D, something like that, okay, and so on. And then we call the connection, it's called a pointer. Okay, you will learn it next week, I think. Okay, what is a pointer? A pointer is a memory address of the next node. So the A is referred to the B, but it's not actually referring to the B, but it's referring to the memory address of the B. Okay, not the B itself, but the memory address of the B. That's called a pointers. Okay. What operation that you maybe have in the linked list? For example, insertion, how to insert the data to the linked list, and the deletion, how to delete data from the linked list, and the traversing, for example, is getting all the data in the linked list, something like that. Okay. This is one of the common ADTs that you will study the first meeting of the data structure algorithm, or maybe in your case is in algorithm and programming too. Okay. Something like that. Do you have any question about the linked list?
Teacher, how can a linked list stop if the reference is like all the way like pointer to the next memory address? How can it stop?
Okay, it's a good question. How the linked list is stopped? Okay, the next pointers always referring to something. Always referring to something. So we have, for example, next here is referring to memory address B. Okay, and then the E is referring to what? Something like that. In the computer memory, we have a special address that called a null. You know null, right? Null, how you pronounce it, I don't, null. Yeah, we have a memory address that called null. Okay, so the next of the last element in the linked list will be referred to memory address of null, something like that. Okay, so when we have the next pointers to null, that's the information is stopped. The linked list is stopped in the null pointers, something like that. Do you understand?
Yes, teacher. Thank you.
Okay. Sometimes that's the end of the linked list. How about the first of the linked list? Sometimes we call is some pointers. We mix one pointers to connect to the first element of the linked list. Sometimes we call it head. Okay. Sometimes we call it first. Sometimes we call it whatever you want. Okay. All you need to have is the reference of the first element of the linked list. And then the rest you don't need to know. All you have to do is traverse the reference to the next linked list, something like that. I think about the linked list you will have a lesson about this in detail next week. Okay. Is there any question about it? Okay, maybe we will have to the next element. Okay, the next ADTs. This is one of the common ADTs. It is called stack M.Q. Okay. This is a stack, the representation of stack in a memory, for example, something like this. So maybe we have some of the data that will need to be stacked. For example, in the real world, when you have a book, some book of a collection of books, okay, how you stack it? The first is you take a book and then you lay it down in the table, for example, and then the next books, for example, book B, will be stacked in the top of the book A, and then and so on, something like that. So, for example, this is a book A, and then you will stack the book B, book C, and so on, something like that. The operation of that is called push. Okay, pushing the data into the stack, something like that. And how about we want to get the book A, for example? How could you do that? When you have a stack of books, for example, how could you get the very bottom of the book of the books? How could you do that?
I think we need to remove the book on the top first before we could reach the book A.
Yes, we have to pop or remove the book from the top, and then the second book from the top, and then until you could have the book, the very bottom of the book, something like that. So we have to pop it, pop it. It's called pop. Okay. Now this is the concept of the last in first out principle. Those you sometimes it's called is LIFO, last in first out. The data that the first in, sorry, the last in, sorry, last in first. Oh, yes. Sometimes it's called first in, last out, philo, something like that. So you inserted a data first, and then you will access the data last, something like that. That's called a LIFO, last in, first out. Okay. What operation in the stack? The stack have two operations. The first is push, adding the data to the stack, and the pop, removing the data from the stack. That's the simple idea of the stack. Okay. And then the second data structure or ADT is called queue. It's maybe very similar. Sometimes stack and queue will be work together, something like that. But the principle is different. Suppose you have to go to the teller in the bank, something like that. You have to queue. You have a queue. Then when you first in, you will be served first, something like that. That's called the first in, first out. So the operation of the FIFO is NQ, or adding the data to the queue, and the DQ, removing the data that in the queue, something like that. So it's not like a stack that you have to push it and pop the last element of the data. In the queue, you will remove the first data that comes first. Okay, the data that comes first will be removed first, something like that. So the operation is something like this. There is the operation. First is a NQ, and then the DQ, something like that. Okay. Do you have any question about it? Okay, this is a data structure is very common in the computer science. For example, arrays. Some arrays implementation were using stack and queue. Sometimes it's the implementation of array using linked list, stack and queue, or the operation of the array usually have push, pop, NQ, and DQ. For example, in Java programming language, when we have an array, it's automatically have the operation something like push and pop in the array data structure in Java. I'm not really sure in the C++ is array have the operation push or pop. I'm not sure about that. Okay. Okay, maybe we could go to the next ADTs. The next ADTs is about the graph and the trees. This is a tree representation. For example, like this, we have some nodes in the tree. Okay. The tree is consists of nodes that connected by the edge. There is the edge. This is the edge. And then the nodes. The nodes is A, B, C, D, E, F. That's the nodes. Okay. The nodes hold the information or the data itself. Okay. For example, we give the data about the structure of an organization, for example. Yes. We could use the tree to represent the structure of the organization. The very top end of the data or the nodes, it's called the root. Okay, the root. And then the very end of the node is called the leaf. This D, E, and S is called the leaf. Okay, leaf. You imagine a tree, you know a tree, right? But it's represented upside down, something like that. The root is in the top and the leaf in the bottom, something like that. But it's just a matter of representation. It's actually not like this, okay? The operation of the trees is about insertion, how to insert the element to the trees, and then the deletion, how to delete the element in the tree, and then how to traverse the data in the list, or how to get all the data in the list, in the tree, something like that. Okay. When we have a tree, it's very efficient when we want to get an information. Rather than we use linked list that is a linear data type. What I call it linear is from accessing the data will be in a linear time, something like that. So the first, second, third, and something like that. But in the trees, it's not like that. Maybe we could use get the data, or for example, the node F. We will get the information in the node F. We only need to traverse from C and then F. But when we use, for example, linked list, something like this, when we want to get the E, element E, we have to do it 5 times. A, 1, 2, 3, 4, 5. Imagine that you will have a very long chain of data. It will have you will need several time. A longer time to access the data. But when we use the tree, it will be very efficient. For example, when we want to get the E, when we use the linked list, we need 5 times accessing the data. But when we use the tree, it's only 3 times. A, B, and E. It's very efficient, something like that. So we need the trees. Sometimes we have the data structure that it's very complex. For example, a graphs. Imagine you have a company, a shipping company. You have to ship some many items to one home to another home, something like that. So for example, this is our headquarters in the shipping company, for example, something like that, and we want to send some parcel or some package into the several homes, something like that. Home B, home C, home D, and E. Every home maybe have interconnected road, something like that. Then how could we do that in the data structure? We could use the graph to represent the data, something like that. So maybe we want to go to the E. How could you go to the E? You could go from A to C or to E, or you could go to A to D to C and to E, or you could go from A, B, D, C, E, and so on, something like that. So this is the data structure that need a complex relationship about the data. So we need a graph. Okay, one node, the data node, it's called a vertex. So and then it will connected by the directed or undirected edges. Okay, and then the edges, maybe we have will have an information such as weight. In our example before, when we want to send some package to one home to other home, The edges maybe told us information about the distance of one house to the other house. That's called a weight. Okay. Something like tree, there is no weight in here. There is only the connection. But in graphs, we have the weight. We have an information in the edge. For example, distance, something like that. Okay. What the operation that we could have in graphs, for example, is adding edge or a vertex, or removing an edge or a vertex, something like that, and traversing all the data in the graphs, something like that. Okay. Do you have any question about it? I think in your syllabus you will have a trace. I'm not sure that you have graphs or some things. I'm not sure about that, but I think you will have the trace. I think the end of the semester of your syllabus. Okay. Do you have any question? Okay, the next, maybe this is the last example of ADTs. It's called the hash table. Okay, the hash table is a very efficient data structure when you could access the data by the hash code, or it called an index. For example, we have many data, for example, here Q1, Q2, and Q3, and then there is some hash function. It is a mathematical function that could represent an index in the data structure. For example, Q1 is the name of the student, for example, like that. And then we will convert it into the integer value, and then from the hash function, it will return an index. So the index will be represented like this. For example, index 0, 1 into 6. Okay, and then the item with the same index will be represented like this. Maybe we could use the linked list, or we could use an array to do something like this. But the uniqueness of the hash table is the hash function. How to design an efficient function that the item will be spread evenly in the data structure itself, something like that. The operation of the hash function is of course, it is generating the hash code or the index, and then the operation, something like insertion, deletion, and searching the data from the hash table, something like that. Maybe the hash table is a very advanced data structure, and I will give you a lesson about it, maybe the end of the semesters. Okay. Because I saw in your syllabus there is no lesson about hash table, but Mr. Chana told me that how about I give you a lesson about a hash table. Okay, maybe we could meet in the last semester. Okay, something like that. So that's. Do you have any question about it? Maybe you don't need to understand now, but little by little you will be understand. Okay. Do you have any question? Okay. So that's what the ADT is. Okay. Many ADTs that composed from a simple data structure, but it will be connected together into the new data structure that will be used for any different problem. Okay, so for example, this is a linked list, and then the stack, and the queue, and the trees, and the graphs, and the hash table. Maybe there is so many data structure that cover in this lesson. For example, the blockchain. You familiar with the blockchain? For example, the Bitcoin, something like that. That's the principle is the hash table actually, yeah. But it is far more complex than that from the hash table. Okay, but you could design a complex data structure, the abstract data structure into your needs, something like that. Okay. Okay. Do you have any question about our lesson? Okay, the next is what makes a good ADTs. This is some consideration when we will design some ADTs. Maybe we want to design some ADTs, but it's not always easy, something like that. But there is some consideration about this. For example, when you implementing some ADTs, it is must be safe from bugs. You have to make sure that your data structure is not buggy, something like that. Okay, because when the data structure is there is some bug in data structure and you use for different for many different projects or many different implementation, it will be very hard to maintain. That's why you have to make sure that your ADT is safe from bugs, something like that. Okay. The second is you understand when you writing the given a name to an operation, for example, you have to give the name of the operation in understandable way. A simple name, and it is a clear name. That's why you have to make your variable name or the operation of the ADTs as clear as possible, something like that. So the user will be easy to understand. Okay. Remember that the users of your ADTs doesn't need to know the implementation. They only want to know what the operation that have in the data structure, something like that. Yes. So you have to make an operation as easy to understand as possible, something like that. Okay. And then we design a data structure that is ready to change. What is the definition? What I mean of ready to change is the implementation of the data structures maybe will be require changing in the implementation. For example, the algorithm, maybe we change the algorithm, something like that. We have to design the ADTs to accommodate something like that. And back to the information hiding, that user doesn't need to know what the implementation that you use inside your ADTs, something like that. Okay, that's three consideration that how to make a good ADTs. Okay, you will learn this. I think in one semester. It is very challenging and very fun, I think. Yeah? Okay, in a fun way. Okay. Is there any question about it? Any question? Wrap up our lesson today. Okay, what we have learned. The first is we learned about the primitive data types. It's just the overview. You already know about it. And then the representation of sign and sign types, you have to know about this. And then overview of abstract data type, what is the data type and why it is important, something like that. And the concept of the abstraction, why the abstraction is needed and what the concept of abstraction, we already learned about it. And the several example of ADTs, for example, the list, the linked list, the tree, the graph, the stack, the queue, and the hash table. We learned about that. For maybe you learn only the surface of the lesson, but in details, you will learn it in several next weeks. Okay. And then the consideration of designing a good ADTs, we learned about that. Okay, I think that's the wrap up of our lesson today. Maybe do you have any question before we end the session? Do you have any question?
No, teacher.
Okay, thank you very much. Okay, I think Mr. Chana is not in this room today. Okay. Okay. I think that's all that I have to. I could give a lesson to you. Maybe we could meet in several weeks about the. I forget about it. About the searching algorithm. Sorry, not the searching, but the sorting algorithm. We will meet again in the sorting algorithm lesson, and then we will meet again in the hash table ADTs. Okay. Thank you for everyone that could meet in this meeting. I will see you in several weeks. Okay. Thank you very much, everyone.
Yes, thank you, teacher.
Thank you, teacher.
Thank you,
Have a good
teacher.
day.
Thank you.
Okay, you may leave the meeting. I will leave the meeting today. Okay. Thank you very much.
Goodbye,
Yeah.
sir. Goodbye.
Goodbye, teacher.